Section 6.11 Wind Turbine Economics. Wind turbine economics have been changing rapidly as machines have gotten larger and more efficient and are located in sites with a better wind. In Figure 6.41, the average rated power of a new Danish wind turbine by year of sale shows a steady rise from roughly 50 kilowatt in the early 1980s to 1200 kilowatt in 2002. The biggest machines currently being built are in the 2000 kilowatt to 3000 kilowatt size range. While the rated power of new machines have increased year by year, the corresponding capital cost per kilowatt dropped. As shown in Figure 6.42, the impact of economies of scale is evident. As we can see, the capital cost of wind system includes the turbine, tower, grid connection, site preparation, control, and land. The 2000 cost is based on wind farm rather than a single wind turbine. And as we can see, the capital cost in terms of dollar per kilowatt hour has been continually reduced over the years. The labor required to build a larger machine is not that much higher than for a smaller one. The costs of electronics are only moderately different. The cost of a rotor is roughly proportional to diameter, while power delivered is proportional to diameter squared. Taller towers increase energy faster than cost increased. An example cost analysis is for a 60 megawatt wind farm consisting of 40 1.5 megawatt turbine is given in Table 6.8. Included in the table is a cost breakdown for the initial capital cost and an estimate of levelized annual cost of operation and maintenance. So for 40 1.5 megawatt turbines at $1.1 million each, so multiply them together is about 46,640,000 dollars. That is as the percentage of total cost, the capital cost, the 76.6%. The site preparation and the grid connection will cost 9.1 million, and the interest during construction and the contingency is about 3.5 million. And the project development feasibility study is about 1 million. Engineering is 600,000. In total, the capital cost is 60.8 million capital cost. The annual cost, the labor and parts is about 1.4 million. Insurance is 135,000. Contingency is 100,000. Land lease is 90,000. Property tax is 68,000. Transmission line maintenance is 80,000. General and miscellaneous is 111,000. And the total annual cost for the annual cost is about $1.965 million. The operation and maintenance costs include regular maintenance repairs, stocking spare parts, insurance, land lease fee, insurance, and administration. In general, operation and maintenance costs depends not only on how much the machine is used in a given year, but also on the age of the turbine. That is, toward the end of the design life, more components will be subject to failure and maintenance will increase. Also, there are reasons for expect some economies of scale for maintenance and operation cost. Section 6.11.2 Annualized cost of electricity from wind turbine. To find the levelized cost estimate for energy delivered by a wind turbine, we need to divide the annual cost by annual energy delivered. To find the annual cost, we must read the capital cost out over the projected lifetime using an appropriate factor and then add in an estimate of annual operation and maintenance. To the extent that a wind project is financed by debt, we can analyze the capital cost using an appropriate capital recovery factor that depends on the interest rate I and the loan term N. The annual payment A is on such a loan will be A is equal to the principal multiply I multiply 1 plus I N scale exponential N divided by I plus I exponential N minus 1. So it's equal to the principal multiply the capital recovery factor. So the capital recovery factor is equal to I multiply 1 plus I, the exponential N, divided by 1 plus I exponential N minus 1. This is table 5.5 show the value of CRF in terms of interest and also in terms of the loan years. For example, if this loan year is a 10-year, the interest rate is 6%. Therefore, the cost recovery factor will be 0.01359. If this loan is a 20-year, the interest rate is 8%. Therefore, the capital recovery factor is 0.1019. Example 6.18, a loan to pay for a small wind turbine. Suppose that a 900-volt Whisper H900 wind turbine with a 7-foot diameter blade cost $1,600 By the time the system is installed and operational, it costs a total $2,500, which is to be paid with a 15-year 7% loan. Assuming O&M cost is $100 per year, estimated cost per kilowatt hour recover the 15-year period if the average wind speed at harp height is 15 miles per hour. It's about 6.7 meters per second. First, the capital recovery cost for a 7% 15-year loan we can obtain from the table or using that equation to calculate. The capital recovery factor is 0.1098 per year. Since the principal is 2,550, multiply the capital recovery factor, we can obtain the A is equal to the $274.49 per year plus the annual $100 per year O&M cost. Therefore, the total cost is $374.49. To estimate energy delivered by this machine in 6.7 meters per second average wind, we can obtain using the capacity factor approach. The capacity factor is equal to 0.087 multiply the average wind minus the rated power P divided by the diameter square. That is equal to 0.087 multiply 6.7 meters per second minus 0.9 divided by 2.13 square. that is equal to 0.0385. And we use the 0.09 kilowatt hour, that is the rated power, multiply 8,760, multiply capacity factor 0.385, which we can obtain the annual energy delivered by this wind turbine is 3,035 kilowatt hour per year. The average cost should be the annual cost of 374.49 divided by 3,035 kilowatt hour per year. We can obtain is a 0.123 per kilowatt hour. Sensitivity analysis of the cost of electricity from a 1,500 kilowatt 64-meter turbine with a levelized O&M cost equal to 3% of capital cost, financed with a 7% 20-year loan, is shown in figure 6.43. The tax depreciation and the production credit are not included. As we can see, the sensitivity analysis of the levelized cost of a 1,500 kilowatt 64-meter wind turbine for the given capacity factor will show that as this is different graph with the cost of electricity and with the average wind speed, which means that as the average wind speed increases in this area, the cost of electricity for different size of the wind turbine will decrease. Example 619. Price of electricity from a wind farm. A wind farm project has a 1,500 kilowatt turbines with a 64-meter blades. Capital costs are 60 million, and the leverage on the M cost is 1 million per year. The project will be financed with a 45 million 20-year loan at 7% plus an equity investment of 15 million that exists need 15% return. Turbines are exposed to really wind average as 8.5 meter per second. What levelized price would be the electricity have to sell to make the project viable? We can estimate the annual energy that will be delivered by starting with the capacity factor. The capacity factor is 0.087 multiply the average V minus the rated power divided by the diameter square. That is equal to 0.087 multiply 85 minus 1,050, 1,500 divided by the 64 square. That is equal to 0.377. The annual energy 40 multiply rated power 1,500 multiply 8,760 multiply 0.373, we can obtain that is equal to 169 million kilowatt hour per year. The debt payment is A for the year will be 45 million multiply 7% multiply 1 plus 0.07 exponential 20 divided by 1 plus 0.07 exponential 20 minus 1, that is equal to $4.24 million per year. The annual return when equity needs to be equity is a 0.15 per year multiply 15 million, that is a 2.25 multiply 2.25 million per year. The levelized O&M cost is 1.8 million. So the total O&M, debt and equity will be 4.24 plus 2.25 plus 1.8 million. Therefore, it's equal to $8.29 million. And the library price at which electricity needs to be sold is at 8.29 million divided by 169 million kilowatt hour per year, which is equal to 0.0423 cents of $0.423 per kilowatt hour is equal to 4.23 cents per kilowatt hour. Example 6.19 leave out a number of other factors that affect the economic viability of doing the wind farm, including depreciation, income tax, and a special tax incentive called the Wind Energy Production Tax Credit, PTC. The figure 6.44 shows the cost of energy from a $1,000 per kilowatt hour for a 50 megawatt wind farm, including PTC, depreciation, financing charge, and tax implications. Section 6.12, environmental impact on wind turbines. Wind turbines have some negative environmental impact in terms of killing the birds, noise, construction disturbance, athletic impact, pollution associated with the manufacturing and installing the turbine. The wind turbine also have positive environmental impact in terms of omit none of the sulfur oxide, nitrogen oxide, carbon oxide, or particulate matter associated with the fuel-fired energy systems. So that completes the entire chapter 6.